Alrighty. We're getting a little late of a start here. Still a little slow this morning from the run Saturday, but it's okay. We got 3 weeks till the marathon. Should be a lot of fun. What are we doing in 3 weeks? Okay, templates. Yeah, that should be fine. It'll be okay. The stairs are rough right after you run a lot. So
Where's the marathon?
I do the International Free Press Marathon, or the Free Press International one. So you run over the Ambassador Bridge, through the Canada waterfront, back through the tunnel, and then a bunch of miles in Detroit. They're not doing Belle Isle this year, which is okay. It's really pretty, but really windy. So it should be okay. This is like the first time we've changed the course in a while. So it should be fun. Yeah, so I think we got through most of what we needed to talk about for inheritance already, which is awesome. So we can probably work a little bit ahead and start talking about some containers. We'll make sure we got all that down. And then remember, on Wednesday, we'll see how long it takes, probably not too long, going over Project Zero and then any other new stuff we need to get into. So that one is coming up due. Hopefully the lab was good practice for you folks. I answered a bunch of questions walking around. It was fun having you folks in lab, although it probably won't happen again, but that's okay. Mr. D is back in town, so he'll come back to working on the labs there with you, and we'll keep on going that way. Okay? All right, so we finish up inheritance. So the lab this week, we'll start on inheritance, and then we'll see if we can get into some containers or not here. Sorry, we're checking out how far did we get in the Zybook, right? So I moved some of these chapters around. So if you had the version from last semester, the chapter order might be a little bit different. Don't worry too much about that. Yes, abstract classes. So we didn't quite finish. That's right. So we got through polymorphism of virtual functions here. This idea of abstract classes, and then UML is actually one of the topics as well that we're supposed to cover, which is really useful here. So if we look at some of these ideas, the objectives, here's our UML one. I thought we had a UML one. Is it not in the objective list? It's just in the description? I'm not seeing it now. No, is it not in here? Okay, well, we still need to talk about it. It's good to talk about. Is it in here? UML. Yes, okay, so it's in our description. There's just not an objective for it. So UML is fantastic. Definitely well worth your time. So I think you talked a little bit in 150, possibly about activity diagrams in UML. Does that ring any bells? You're like, hey, this code will do something here, and then something else might happen over here, and something might happen over here, and that maybe is as much as you got into. Does that ring any bells? Okay. So Visio is a great tool. The lab has Visio. It usually costs a bunch, so I think it's silly, and there's some free online tools that do most of what we need it to do here. And then even I just draw stuff in Word because I'm lazy, and it comes across pretty well. But if you just look up like UML online, Lucid Chart is pretty popular. You can start free, and then they want to charge you money. Visual Paradigm is a really fancy tool that will generate code for you based on your diagrams, which sounds really cool and is kind of neat, but then you still have to do a lot of the work anyway, and they cost a bunch of money. Where's the really nice free one? Search free. Free edition. Okay, so they do have a free one. There you go. They want people to use their stuff and start getting into it. Maybe it was Lucid Chart. Someone else had a really nice one. Wow, all of them. Isn't it like Draw.io or something? I forget. Draw.io. I'm searching draw.io and I get ads for Lucidchart. This is what you do. You have to, here we go, gives draw.io. I will decide later. Yeah, draw.io is pretty handy. You can just drag in your shapes, figure out what you want to do here for all sorts of fun UML types here, right? And then they have their own UML category. So UML is nice in that it is a standard, right? You should be able to use this anywhere. Not everyone actually does all of the pieces for it though, but that's okay. So these class diagrams are my favorite here. So you drag in a class diagram. It's a little small. Let me see if I can zoom it in a little bit here. Is that any better? Okay. We can go larger if we need to, but the idea with a class diagram is it's going to give you a picture of what's happening in this class. And you see it's pretty handy here. Let me open up Visual Studio. And maybe we can draw a diagram of our class. So we were talking about inheritance. Excuse me. We looked at a couple classes here. So we had this item class. So when we're doing our diagram, the class name goes at the top. So this would be item. It's pretty easy. So it's got 3 sections. The middle section is all of the fields or attributes. So, and then you add some additional notation here. With UML, there's a plus sign to indicate public and a minus sign to indicate private. So if fields are private, they start with a minus sign. If they're public, they start with a plus sign. And most of what we're going to pretend and say good design is you have private attributes with public methods. It's not always the case, but that's a good starting point for us to assume. Let's start here, unless you have really good reasons otherwise. And for our purposes, we don't. We don't have anything that has a good enough reason we need public attributes. So we'll have all of our attributes, and then the notation here is a little bit backwards. So you give it the name of the field, colon, the type of the field. Rather than type variable name, it's variable name type. I don't know why I didn't come up with it. It's just what UML does. So we say, okay. So we will look at item then has a name, a price, and a quantity. So we can add those in here. So we can say, hey, I have a name, which is a type of string. And this is minus, it's protected here. And then I'll have another one. I have a, oh goodness, I have to resize this individually? I do, sure. Why not? Then we have a price, right, which was a double. And then we have a quantity, which was an integer. Right? So we're just listing out our attributes. So you don't actually need to see any code. You can just see this in a picture and you can imagine the code you're going to write. So this is also why naming your variables and naming your methods or your functions is very helpful. Because if all you get is this picture here, you probably will still know what's going to happen. You might not know all the details, but you'll get, okay, this is the high level, what I'm going to do with it here. And then we list out our methods. So again, you can have private helper methods. There's nothing wrong with that. We would just indicate that it's private with the minus sign, or we can have public methods. So all of our public gets and sets, those sorts of things here. And then if it takes arguments, we also list out the arguments. So the colon on the right-hand side is the return type, either void or if I'm going to return an integer or a double or a string, anything here. And then in the parameter list, we could specify those as well. So these get a little long sometimes. We got to try and open this up a little bit here, especially when we start looking at our constructor. So we're going to have an item constructor here, right? And then that takes our variables here. We had name, double, and quantity, right? So we had a name, which was a string. Again, it's backwards. So name, colon, string, variable name, colon, type. It's always backwards. And then we had a price, colon, as a double, and we had a quantity as an int. And then this one didn't return anything as the constructor, right? We don't even really need to add the type here. Then we can add all of our get methods. So we had like a get name, didn't take any arguments, it returned a type of string. We had a get price, returned a double. We had a get quantity, returned an int. Right, all of our get methods, and then we had the set methods, right? Because we could change some of these things. So we had a set price, which took a price as a double. As void, didn't return anything, or just leave off the type. It's common. Sometimes I like putting void in here just so people know I didn't forget. Let's be honest, sometimes we just forget to indicate things. So we're a little bit more explicit that, yes, I know I'm not returning anything, can be helpful for people looking at these. And what else do we have? We had a set quantity and a get total price. So we had a set quantity given an int quantity as an integer, and then we had a get total price. Get total price, didn't need any arguments. This one returned a double. Right? And that's it for our UML. So this is not very interesting to look at after the fact. But what's cool about UML is you can do these before you write any code. And you can think about, oh, what attributes and what methods do my classes need as I'm designing my solution? And then when I'm talking to someone on my team, I can say, hey, this is what I had in mind. And if they have ideas or they think, oh, maybe we should change this, maybe we could write it this way, or maybe these attributes belong in a different class over here, all I have to do is change my picture. I haven't written any code, so there's not really any waste of time, right? Hopefully you got drilled into your head. The more time you spend planning what you're going to do before you write the code, the easier it is to write your code. Right? Did that ever happen to you last semester or like these first couple weeks? Like if you just start writing code and you don't really know exactly where it's going to go or how you're going to do it, you're going to spend a way more time struggling with your code. But if you spend a little bit of time ahead of time and think, okay, these are the functions that I need to have, these are the attributes that I need to be working with, and then you know what you're going to write, then you can go write it. Kind of like making an outline before you write your paper. If you know what's going to happen in your paper here, okay, I'm going to talk about this, and we'll talk about this section, and I'll have this section, and this one will support this section here. Then when writing it's so much easier. You're just kind of filling in the spaces there. Hitting that word count, the minimum page count, whatever you have to get for papers, because obviously that's what matters. Okay, so that's a basic class diagram. And these are relatively standard. You'll see them a lot, and it is very nice to do these ahead of time when you're working on something. Because you can say, oh, just visually, these are all the attributes, these are all the methods. And if our methods are named well, you probably know what's happening here. Even as code gets more complex, if you name your methods well, you probably get a feel for what's happening, even if you don't know how it's going to happen yet. You at least know, okay, this is what needs to happen in the method here. Right? And then you get a whole bunch of fun arrows in here. So, oh my goodness. Depending on the right arrow here, got way too many of these here. Association, turn, dependency. Might just be, I think just relation is probably the easiest arrow for us. They've got a bunch of different, nope, put that back, not the arrow. If you are going to inherit from a class, you can do that in UML as well. You just draw an arrow. The relation might not be the right one here. There's got so many of these. Checked. And every tool has them like listed differently, but that's fine. Turns. Just the association. There we go. That's the one we wanted. This will indicate our parent and child relationship. So the parent class here is going to be our item, right? And then the child class can be whatever we want from here. Why is that? It's in a weird spot though. Sure. Don't worry about making it pretty right now. It's not really all that worth it. And we'll just bring in another class diagram here. Wow, it's really helpful adding those. Oh look, it even added as the child. That's fun. Sometimes tools are helpful. So then we could add in something like our taxable item. Right? And the arrow indicates that relationship for us. So I don't need to repeat any of this stuff here. We can just add in here, this is our taxable item, right? And then taxable item had the tax rate as a double. And that was about it, right? I think we had a set tax rate and a get tax rate. Yes, set tax rate, get total price. Oh, the constructor. We had a constructor. Let's make this a little bigger here because we're going to need room for that constructor. We had a taxable item constructor that took a bunch of arguments, right? We had a string, name for string, name as a type of string. We had a price as a double. We had a quantity as an integer, and then we had a tax rate as a double. Colon, double. There we go. And of course, make that a little larger. This is why I do these in Word half the time. The tools are only so fun. Come on. All right. And then a get tax rate, return the type of double, a set tax rate, given the tax rate at the double, and then finally you get total price. Return the type of double. So we do want to specify the get total price because we're overriding that behavior. Right? This is a method in taxable item. Again, sorry, it's boring to do this after, but then we know what we're kind of putting in here at least. Okay, so we can see that relationship, and then we can draw another box and draw our other one for a perishable item, and then so on and so on and so on. You can have all sorts of levels of these relationships, right? So I could have something that is a type of taxable item if you wanted to inherit from taxable item that did something else, and you can have something that inherits from that. You can go through all these levels here if you want. Right? There's basically no limit to how far you want to inherit for our purposes. Okay, so that's some basics with our UML class diagrams, giving some pictures here. So the next project, I'll ask you guys to do class diagrams for practice. If you do them ahead of time, it's really good. When you turn it into me, I won't know which one you did first. Okay, but if you do them ahead of time, it will go better for you. We'll just that's part of this design process, right? If you spend a little time thinking about what we're doing, figuring out how we want to solve the problem, it's easier to actually solve later, right? We can just take these and go. And that's where some of the fun tools like that visual paradigm tool could essentially build out a class with basic get and set methods from a picture like this. If you pay for it, I don't think the free one does it. Their paid tool does stuff like that, which is nice. So it saves a little bit of time you typing. The basic gets and sets that it can do though automatically are like really fast to do anyway. So it saves a little bit of time, and that's nice. And good programmers are lazy, so we don't want to do more work than we need to. But it's not really hard work we're avoiding, so it's probably okay at that point. Okay, how are we feeling about UML? Not too bad. So the class diagrams are new, right? The activity diagrams you might have done, you might have said, hey, this has to happen first, and then this step, and this step, and this step, those sort of things. So you can still do those with your classes as well, which are really fun. And then you can kind of illustrate how classes will talk to another class and they'll interact with each other. Yeah.
Will you be uploading this on Canvas, or will we just have to go back to the video?
Let me see. Sharing for Google Drive and OneDrive files. I can probably just save as. How about that?
Or print it on PDF.
Ooh, we can do an SVG file. Does it have a print as PDF? I think there was a PDF option. Above close. I'm
very above.
Thank you. Okay, you said up, and I'm just confused. But above close. I got you. Yeah. Sure, we can make it a PDF here. Look how pretty that is. All right, let's put that here for now. This is item and taxable item. Well, sure. And I'll put that in Canvas. Where do you want to put that? Like miscellaneous? How about that? We'll just add a miscellaneous spot and drag that in. Why does this not work with is this just Windows 11 now? It doesn't let you, like, it used to open things when you did that. Now it doesn't. Okay. Should we date that too? This is 2022-09-26. There. So that way you can match it up with that later if you want. Or should I put it in the archive? Does it matter? Okay, we're spending too much time thinking about it. I'm sorry. It's not that important. All right, so it's some UML. So abstract classes. This is where it starts to get really fun. So when we're talking about inheritance and abstract classes, things get a little bit more interesting, which is kind of cool. It's nice that we can do this sort of thing here. So I'm going to go and make have the whole project for inheritance. Maybe we'll just leave it in here. So let's add a new item in here. I want to add a new header file, and I want to call this a polygon. We're going to start with Polygon. we're going to write a class for Polygon. Right? We're going to have private attributes and public methods, this sort of thing. Now, when it comes to polygons, hopefully you're already thinking, hey, we were going to do something with inheritance because we're talking about inheritance, and there are lots of polygons and there are lots of other geometric shapes that are polygons, but they're like special versions of them, essentially, right? So one thing that Polygon has in common is they all have sides, right? They're all some sort of shapes. And we're going to essentially assume that you're giving me closed shapes here, because otherwise geometry gets really hard if you don't close all your endpoints. And I don't know how to do all that sort of math. So we're going to look for just basic closed polygons here. So what we'll have then is an integer for number of sides, right? We'll know how many sides we have for a given polygon that we've created in memory, right? So Polygon is just that template. It's just the blueprint for it. We should have done a class diagram first, but that's okay. For the number of sides. And then we need to know the length of our sides. So we've used a lot of dynamic memory. It's wonderful, lots of fun, but I just want to use a vector because life is easier if we use a vector. So I'm going to use our namespace for standard, and then we're going to include vector. So when we talk about the side lengths here, I want to have a vector of probably int here. I guess we could do doubles. I don't know. Yeah, let's do doubles. So that's probably a little more flexible here. This is for my side lengths. So I'll have a list of lengths for all of the sides that I do have. So if I have 3 sides, I'll have 3 side lengths. If I have 4 sides, I'll have 4 side lengths. 5 sides, 5 side lengths, on and on and on. Yeah.
I've heard before that you shouldn't use libraries in your headers. Is there any truth to that?
I mean, we're the include portion, or just
in general?
We're going to use everyone else's code all the time.
Yeah.
Right. Trying to not use someone else's code is silly. There might be some performance implications. For our purposes, we don't care. We're not caring about speed right now. This is just our second semester coding. When you get to 350, you'll have all sorts of fun with Dr. Ortiz or whoever's teaching it, and you will care about speed because you'll be graded on that and that sort of thing. We're just going to include it now, and it should be fine because we need vectors right now to do this. I mean, we could use the dynamic memory, but there's all sorts of other stuff we're going to look at in the library that we're going to make use of later too, and our classes will use them. So I don't know where that came from, but I'd be curious. There's probably a reason someone said it. Okay. Yeah, maybe. So other attributes of Polygon. If we just know how many sides we have and we know our side lengths, we should be in pretty good shape here, right? Then what we can do is other things that polygons know how to do is they'll know how to calculate their perimeter, which is pretty easy if we have a list of our lengths, right? Perimeter is pretty easy to calculate here. So we can have a double for get perimeter. Perimeter? Is that right? I can never remember on these. I'm sorry? Okay. And that one's pretty easy here. We probably also need a constructor, right? If we want to make a polygon, if you tell me how many sides we have, right, an int for number of sides, then we can go through and create these and figure them out. Now, setting side lengths gets to be a little trickier, and we'll get to that in a minute here. We can say this number of sides is my number of sides argument, great, and then we can create the side lengths here of a given size. Right, so we can default them all. So with our vector, let's see what our vector we do. Vector double. I think we can specify how many we want, right? Yeah, we can give it one of these. Yeah, the size. So we'll have the number of sides of them, and we can default it to 0 because we don't know otherwise. If you want, right? When we talk a little bit about vectors, you can give them how many to space in there so that it is sized ahead of time instead of just pushing back every time. That helps your performance, and you can give it a default value if you want. So right now we have a bunch of zeros, and that's probably okay. So getting the perimeter, then we just need to loop through all of our items in the vector and sum them up, right? So we'll have a double for the perimeter, starts off at 0 until we know otherwise, and we can loop through You can use index if you want, right? Lots of fun ways, however you want to loop through your vector. Index is less than my side lengths dot size index plus plus, and we'll take our perimeter and we'll add to it my side lengths at the index. Right, nothing super fancy here, I hope. We'll return the perimeter. So we can calculate it. Right now it's going to be 0 every time, but then we need a way to get and set side lengths as well. So we'll have a void for set side length given the index and then the length. So if you tell me which side index it is, I can go set the length for that index. Now, again, if you try and get at an index that doesn't exist, bad stuff will happen. I don't think we need to do any special checking on our own to make sure that's valid, because vector will just puke on us. If you try and get index 10 out of a vector that doesn't have 10 indexes, right, vector is going to puke on you. So like us trying to write our own custom exception here, we haven't really gained anything, because vector is already going to yell at us. So we can just try it. So we can take our side length at the index, and we can assign it the length, right? It'll either work or it won't, and that exception will just happen, right? So whoever called this code will have to deal with that or crash, which is fine. And then we could have a double for get side length for a given index if they wanted to get out a specific length. So we can just essentially return that. Right? So we can set, we can get the perimeter out. Okay. What other things can polygons usually do, assuming they're closed? What about area? Do we calculate an area? Can we calculate an area for any polygon? Do we have enough information though to calculate an area? If I just tell you here's some side lengths? I feel like no, I don't actually know mathematically. Okay, most of you are shaking your head no. You probably know more math than I do. So, but polygons should be able to calculate an area if we know what kind of shape that they are, right? So if we know triangles, great, triangle has a formula. If you know rectangle, great, rectangles have a formula. If you know, I think any shape you can say probably has a formula, right? Probably? I'd imagine so, but again, math is not my strong suit, I apologize. So what we can do then is we can use this idea of an abstract function, which is really fun. So we get to say, hey, I will do this thing. It's a virtual function. So we're going to mark it as something that should be able to be overridden with our virtual keyword, and then we're just not going to define it. We'll say, hey, my subclass, my child class, my derived class will figure out how to do this, but I don't know how. So we can have a virtual double get area, and you say equals 0. So this equals 0 when you define a method is our notation for saying it's abstract. I will have a function, but I don't know what it's going to be yet. So we're saying we're just going to make the subclasses figure this out for us. Now, why this is useful, remember when we looked at if you have a list of pointers to a class and you call a method that's been overridden or a virtual method, you'll get the correct version. Right? We looked at that with our items here. If we have pointers and we print the total price, we get the correct version. Even though we said, hey, it's just an item, whatever actual type of item it is, whatever subclass of item it is, we get the right version here if we're dealing with pointers. Okay, so at the top level here, if I add a method or a function here, I say, hey, I will be able to calculate area, then I can have a list of pointers of type of polygon, and when you ask for get area, you'll get the correct version. If there is no function defined here, then there is no method get area in Polygon, and you can't have a pointer to Polygon and get the area out of it. So then your list would have to be specific of it is a rectangle list, or it is a triangle list, or it is a hexagon list, right? And then at that point, we can't have different subclasses all in one list here. So defining it and marking it as abstract will guarantee that if I have a pointer to a polygon, it thinks that method exists, because it does. Right? So when our subclasses override it, we're in good shape. So if we want to go and make a polygon, let's call this one a square, right? Because we'll be specific here. And then we'll say, hey, it has 4 sides. Oh, we should include polygon, shouldn't we? Polygon. There we go. But now it says, uh-oh, we can't make one of these. Object of abstract class type polygon is not allowed. If the class has an abstract method here, I should mark this as the equal 0. It's pure virtual or abstract. That's our technical term for it here. If you have an abstract method, a purely virtual method, you can't have an instance of this class in memory because there is no definition for this function. And C++ doesn't know what to load, right? The method exists, but there is no definition for it, so it gets really confused. So you can't go make a polygon directly because it's abstract. It has a pure virtual function. So what we can do then is then we need to start subclassing that class. So we can make a new header file, and we can make triangle, right? And triangle can be a type of polygon. Nope, come on, polygon. There we go. Probably need to include it, don't we? Nope. Polygon. There we go. Okay. Now, before, when we looked at our constructors here, item needed a bunch of things, right? So when we subclassed item with like perishable item, we needed all of those things, and we just handed them to the item constructor. If I'm making a triangle, do I need to ask how many sides are in the triangle? All right, good. Everyone's saying no. Thank you. You all know this here. So I'll have a private section, we'll have a public section. So if we're making a triangle, then our constructor doesn't need any arguments here. But when we call the polygon constructor, we can just tell it it has 3 sides. Right? You don't have to have a variable here if it's not variable. So the polygon constructor just needs to be told how many sides it has. So as long as you tell it how many sides it has, this constructor is fine. Right? So this is a weird way of thinking because we haven't really done it like this before. We know what it is. Right? So that's it for triangle. That's all we have to do. We don't really need to do anything here. I'm fond of this comment. I don't usually do comments here, but this is like telling someone that you know your constructor is empty because usually it looks really weird here. Just a convention. There's no like requirements here. This is just a common habit I've gotten into. Again, it's nice to tell people you know something's blank, or like otherwise it's really easy to miss those sorts of things because people forget stuff all the time. So, all right, cool. So triangle, great. We're in good shape then, right? So now let's see if we can make a triangle. Okay, so let's make we got to import triangle, or include triangle. Triangle. We can make a triangle. Triangle, small triangle. Now it doesn't need any arguments here, right? Just have some triangles. And then we can take our small triangle. Maybe we can take our small triangle. Come on, IntelliSense. Dot. Uh-oh. It's not liking it here. It's not erroring there. It doesn't like a triangle. We build? Let me just see the builds. Maybe we'll get some errors here. Okay, sure. Small triangle. No, still unhappy with my triangle. That's okay. We didn't actually finish implementing it yet. It wasn't supposed to really work, but that error was not very helpful, right? Because triangle doesn't implement our getArea function yet. It really doesn't work. So we need to figure out this getArea. Yeah.
Maybe just include polygon.
So if we're including triangle, when it essentially copy paste, it's going to also include polygon at that point. So it's sort of like including through the include. It was just to save one line of code. We can put it back, but I don't think it'll do anything here. I think it's still just because it's not. Oh, is that really? No. Right? IntelliSense was getting it here, but now nothing with the dot. No, it's still not in good shape here. So we need to go and write that function. Was sort of the idea here. Now, for triangles, our area is 1/2 base times height. But if we only have side lengths, do we know what the height is? That's kind of annoying. So maybe we'll say, to make life easy here, this is a right angle triangle. How about that? We'll be very specific. This is a right angle triangle. Because that one we can calculate with base and height, right? If we know the side lengths, right? Okay. So let's do that one here then. So then we're going to have our double for get area. So we're going to have 3 sides, right? The 2 shorter sides must be our base and height. The longer side doesn't count, right? Okay, so we need to find the 2 shorter ones, I guess, or which one's the long one and exclude that one, right? Any other smart math ways of doing that? That's all I got. Sure. Okay, so we'll get the length 1, length 2, length 3. Figure out which one's big, get rid of that one, multiply the other 2, take half of that. Sure. Okay. Cool. So we'll have a double for side length or side 0 length. Sure, why not? We can get our side length of 0 and 1 and 2. Right, why not? Probably a better way to do this, but this is okay. Doesn't have to be pretty. Okay. Then we need to find out which is the biggest one and not use the biggest one. Sure. If side 0 length is greater than side 1 length and side 0 length is greater than side 2 length. This is really ugly. I'm feeling bad here, but you know, it'll get the job done. So if this one's the long one, then we can return side 1 times side 2, oops, 2 times 0.5. Otherwise, let's check the next one. I want to copy. I guess we could do else ifs, why not? And then this can just be an else. That'll save us some time. So otherwise, let's see if number 1 is longer than 0, and if 1 is longer than 2, then we need 0. Right? If it's not 0 or 1 is the longest, it must be 2. We'll do 1 times 0. Yeah?
I mean, you could use Heron's formula. So like take all the sides, divide by 2, then take the square root of that, times that again, plus the side length 1 times.
That formula sounds really cool.
It covers all of it though, so like then we don't have to talk about that.
Nice. I have no idea what that formula is, but it sounds really neat. What was it?
Heron's formula.
Formula triangles. A triangle when only the lengths. You guys, you didn't tell me about this. I did a right angle triangle specifically. This is fantastic. So we could have done any triangle. Didn't have to be a right angle triangle. Okay, I like it. The semi-perimeter? I don't even know what a semi-perimeter is. Semi, okay. Like a semicircle is a half circle. Look at that. Sometimes words make sense. Sometimes. The area is the square root of... Wow. This is fun. Okay, let's do that. Let's try that. I like this. So now we don't need to be a right angle triangle anymore. It can be just a triangle. All right. I don't know how to do any of that. So we need the semi-area. Semi-perimeter, thank you. Semi-perimeter meter is my get perimeter divided by 2. Right, there's our semi-perimeter. Fantastic. So we've got that. Then we're going to take the square root of that times that minus all the side lengths. Okay. So we'll have the next one here. So that's just the area then, right? We just get the area. so that we can return f dot square. F dot, oh my goodness. Square root's just built in, that's right. So square root of the semi-perimeter times the semi-perimeter minus get side length of 0. Look at that. What a cool formula. Where should we put those? That's fine. Times. Nope, that was needed that parenthesis. Side 1 times that of side 2. Is that it? Look at this. We're gonna add a notation here. How cool is that? Because I have no idea where that math came from. But that is really, triangles are really neat. They're like some pretty cool shapes. Thank you. I learned something today. It's a good day. Okay, so we can calculate the area of our triangle. Life is good. Now let's see if we can go back and make a triangle. Now is it gonna be upset with us? Small triangle. It's still gonna be upset with me, isn't it? Small triangle. Why does it hate my small triangle? Did we do something wrong here? Triangle constructor. Creates a polygon. So we don't actually even have any private fields either, right? We just have public. Right? There was nothing private. Worked out pretty nice. We do our small triangle dot. Get area. Actually, we probably should set some sides first, right? Is a variable definition intended? Prototype function not called. I'm super confused why it doesn't like that. Sometimes these errors are not very helpful. Need a pointer? I don't think I need a pointer. Try a pointer. The new triangle. Get area. Okay. Oh, look at that. It likes it. Likes it as a pointer. All right. So we can get the area out. Sure. Oh, it's not very interesting without another one. So let's do one more. Okay, this one will go better than triangle because I know the formula for this one, I promise. Okay, so let's do a rectangle. All right, rectangles are easy. Include polygon. Okay, so then we'll have a class for rectangle, which is a public polygon. Now, we're going to run into some trouble here, though, with rectangle, because if you individually set side lengths here, you can get your rectangle into a shape that is not a rectangle, which is bad, right? Classes need to make sure they're maintaining their integrity. So if we need a way to change the behavior of set side length, we need to make sure we can override this method. So we need to make sure this one is marked as virtual so I can change its behavior later in my subclass, right? So rectangle then, again, we don't need any private attributes here, but the public rectangle constructor can just tell Polygon, hey, you have 4 sides, right? That's all we really need to do. Then what we want to do is we want to change that behavior of set side length, right? Given an int for the index and the double side length. Because if I set a length, I need to set both lengths. If I set a width, I have to set both widths. Otherwise, I'm going to be in not a rectangular shape, and rectangle depends on being a rectangular shape. Okay, so I'm going to change the behavior of set side length. So I can say, hey, if index is, how about we say mod 2 is 0, right? We'll say these are the even sides, right? Or you could just say if it's 0 or 2, we don't really care one way or the other. This way's fancier, right? Might as well use modulus because it's a fun operator. So if it's 0, we're going to set side length. Now we need to use the polygons version. Polygon set side length. How do we do that one again here? My goodness. double colon, thank you, polygon, double colon, set side length, 0, and the side length. And we'll do it again then for side 2. Right, so if you set 0 or 2, we'll do it for 0 and 2. Right, that way we're keeping our length the same. Otherwise, we'll do it for 1 and 3. Right, this way we make sure you're setting both sides or both widths, or both lengths or both widths. Right, we need to change that behavior. Then, to get the area out, yeah.
Would that also mean that if you put the indexes like 11 or something, 1 and 3?
So, yeah, that's true. So it wouldn't fail at that point. So maybe we could do some sanity checking here. Maybe is it better to have some if else's? It might be. If you're trying to set index 7 on a rectangle, you deserve to have bad things happen to you anyway. But no, that makes sense. We should probably check for that. So we can say, hey, if index is greater than or equal to 4, right? Because we know we don't have a 4, or we should just say greater than 3, right? Or we can't even get side length. That's fine. Greater than side length. So we'll throw a logic error. Rectangles have that many sides. Okay, so we'll just throw up on them anyway. Now, people might be confused because indexes start at 0. We don't always remember that, but programmers are going to use our rectangle class, not math majors. So they'll know to start at 0, and we'll be okay. All right. Well, the math majors can get confused. It's okay. I'm using a semicolon. There we go. All right. Cool. I like that. So then forget area. Right, this one's easy. We can return our get side length of 0 times the get side length of 1. Boom. Look at that. I told you I knew that formula. Okay, that one was easy. Then we can go back in our source file, right, and we can have we want some sort of list of shape polygon pointers. The whole reason we wanted to have this class so that we can have just a bunch of polygons and figure out their shapes and those sorts of things here for fun. So I can have a polygon, we'll call these a pointer for shapes equals a new polygon, and let's just put like 5 of them in here, right? Oh, but there's no default constructor for Polygon. That's a bummer, right? If we don't have a default constructor, we can't create an instance of Polygon to go in memory here. Well, let's see. Number of sides. Can we default it to something? If we wanted the default constructor? I mean, default it to 0. That's not great, but I mean, an empty polygon is not really great anyway. Now why is it upset? But no, it's abstract. We can't have it. Well, we can't have it anyway, right? Because there is no good constructor happening here with this. So didn't really gain anything here. Where did our source go here? Right. But if we have a single pointer for Polygon, or we have some sort of function like print item cost, we can do it. We just can't have a collection of that main type. So we can just go add our own void. How about we'll say determine larger polygon by area. Given a polygon pointer, first polygon, and a polygon, let's call it first, and a polygon pointer per second. So if you give me 2 polygons, we can figure out which one is the larger one by area. And maybe we'll give you back a polygon pointer. Right? So we'll return the larger one. Okay, so we don't need the collection here. We'll just have a triangle. So we should figure out the triangle's side lengths here. So our smallest triangle, we should set a side length of 0. And how long should these lengths be? Let's make up some lengths. 3, 4, and 5? Sure. And we're going to be a right angle triangle anyway, after all that work. Sure. 3, 4, and 5. Okay, cool. And then we can make a rectangle, angle pointer, called a small rectangle, a new rectangle. Oh, I didn't include rectangle, did we? Include rectangle. Include, thank you, rectangle H. There we go. Make a rectangle, right? And then we'll set the side length of 0 to what? 5? Sure. And what's the width of our rectangle then? I heard 2 first, sorry. Okay, so area should be 10, and area of this one should be 6, right? Okay, so we'd expect rectangle to be larger. So then we'll get a polygon pointer. This will be the larger polygon equals my determine larger polygon by area, given a triangle, my small triangle, my small rectangle. Okay, we'll see which one's larger based on the area here. So to do that one, then we need to see which area is bigger. So if first dot get area is greater than second get area, return first. Otherwise, return second. Sure. Okay, and then we've got a polygon I can work with here. And not very interesting here, but we can. Did we not do? Yeah, we did that. See out. Okay. See out. Wrong word. The area of the larger polygon is larger polygon get area. And probably an end line. We like end lines. So we should get out 10. Or no, area was going to be larger than that, right? No, 10 was right. Where did that go? Did I do something wrong with it? There it is. Look at that. We got the larger polygon by using an abstract class. So that abstract class doesn't have everything fully defined. Right? We used a pure virtual function with this crazy 0 notation. Right? So we're assigning it to 0, making it abstract. You can't create polygons. We can create subclasses of polygon and have those be created. That way they all share the same function. This doesn't seem like it's all that useful yet, but what this lets you do is essentially take shared behaviors like we did for Polygon, put them in a class and say, okay, but they will also have these other methods. I just don't know how they're going to do them yet for these sorts of things. And then you can get even further along and you can have a fully virtual class or pure abstract class that has nothing but these function definitions. So here's this class. All it has is I will have these functions, and then we're going to go implement it other ways. We don't know how yet. And as we start looking at building out our containers and ADTs, yeah, we didn't get to containers. That's okay. So we didn't have to get to containers. We start looking at how these containers work. This will make a little bit more sense. Maybe we'll get there. It's not even going to load. That's fine. There it goes. So as we start working with these containers and ADTs, these abstract data types, we know there's some behavior and we can implement that behavior differently. So when we look at how linked lists work versus vectors, they'll behave the same, but they have different implementations, right? And the reason why the implementation matters is because it will change the speed at which it can do operations, which is really fun. So linked lists are faster at some things than vectors. Vectors are faster at some things than linked lists. So if we understand which one is faster, when you are using one, you can make a choice to use the one that's faster for what you're doing with it. But they essentially look the same. So if they both have the same shared set of these methods here, we can use them interchangeably later down the road. We're not forced into one specific type, which is really fun. Yeah, thanks for following along, my friend. All right, that was a lot. This was new stuff, right? We're finally getting into new stuff. It's no longer review. Sweet, that is good. That is good. Review's boring. It's good. It's good to review things for sure, but review's generally a little bit boring. So we want to get into new stuff. That way you're like might actually want to pay attention. Maybe. It's okay. I get bored when people review stuff too. It happens all the time. I don't have much of an attention span. I'm sure you haven't noticed. So, but that's okay. All right, just one more thing, and then I think we're good to go. I'll give it Mr. Dia, make sure we can get the lab posted. But I heard this. My son was telling me, so it was his birthday. He had some friends come over, some family come over, and he was telling me, he's like, Dad, I don't trust trees anymore. I'm like, why? What happened? Like, did an apple fall on your head like Newton? It's like, no, they're always shady. It's like, yes. Even if he's not into coding, at least he'll tell bad jokes. Made me very happy. All right, I think that's all we got today. So we'll come back on Wednesday, and then we can actually pick up some of the containers and go from there. All right. All right.
Quiz is going to be due Wednesday.
Oh yeah, let me change that. I'll push the due date out for you because we basically finished it, but that's okay. Let me go edit that here. Yeah, so I'll push that. We'll try and keep those on Wednesdays just to make that consistent, because otherwise that gets weird. There we go. All right, the 28th for the quiz. Sorry if you pushed through to get that done early. All right, awesome. Thanks, folks. I'll see you Wednesday. Thanks, everybody online.